Okay, now we want to look at simplifying some rational expressions, starting with this fairly simple looking guy. X squared plus 7x plus 6 divided by x squared minus 2x minus 48. Now, the thing to keep in mind when it comes to simplifying these rational expressions is that you have to know how to factor. Because once we can factor, then simplifying becomes a pretty simple task. So, starting with this numerator, we want to factor this trinomial. So, factors of 6 that add to 7 would be 6 and 1. So this is going to factor as x plus 6 times x plus 1. And then we're going to look at that denominator. We want to find factors of 48 that will subtract to 2. And so those factors would be 6 and 8. We need to make sure that we get the correct signs though. So we need to have a positive and a negative in order to end up with a negative 48 here at the end. So one has to be positive, one is negative, and since the middle term is negative, the larger of these two factors must have the same sign. So the 8 needs to be negative, which means the 6 needs to be positive. And a quick check of this will see that you will get a negative 48 when you multiply these, and when you check the inside and outside pieces of the FOIL method, you get a negative 2x when you combine those guys. And now we reduce away those common factors, because x plus 6 over x plus 6 will reduce. And that's one of the things that we need to understand, is that x plus 6 divided by x plus 6 is equal to 1 for all values of x not equal to negative 6. So in this original expression, this big nasty looking fraction is the exact same thing as x plus 1 over x minus 8, as long as we know that we can never plug in x equals negative 6, because x equals negative 6 would have made this denominator equal to 0, which would have made the whole expression undefined. I could plug negative 6 into this guy without a problem, but we need to always remember, where do we come from? We came from an expression where x equals negative 6 was a restricted value. Okay? So here is our answer. Okay? And that's the really neat thing about this, that when you have something divided by itself, it always gives you 1, as long as you're not going to plug in a number that would cause it to be undefined. You could plug in 100, you could plug in negative 1,000, and when you do that, you're going to get a 1. But if you ever plug in negative 6, you would have 0 divided by 0, which would now make that expression undefined. Okay, so that's why we have that little statement there. Now this next example is about multiplying. Well, pretty simple. When it comes to fractions, you just multiply straight across, but we don't want to do that. You don't actually want to multiply this trinomial times that trinomial. It's going to be a pain to do that. It's going to get big and messy, and it's not helpful. Instead, what we want to do is we want to see if there are factors that can simplify before I multiply. So in order to do that, we want to take each of these expressions, each of these polynomials, and factor them one at a time. And so, yeah, you can think of this as being 4 separate factoring problems, right? So up here, this is a nice trinomial. Lead coefficient is 1. What are the factors of 4 that add to 5? Well, that's not too hard. That's going to be x plus 1 and x plus 4. Now this denominator is going to be a little bit more difficult because the lead coefficient is not 1. You can do the AC method. We've seen videos about that. We've practiced this many, many times. 2 times 4 is 8. And can you find factors of 8 that give you 9? Yes, 8 and 1. All right, so we're going to have to make sure we do a combination there with the two binomial factors so that the inside and outside pieces give you an 8x and a 1x. So you can take this guy off to the side and just do some scratch work on that. Surely got some scratch paper around here somewhere. And you can rewrite that 2x squared plus 8x plus 1x plus 4 and do factoring by grouping that way. So the common factor in that first group is 2x, and we're left with x plus 4. In the second group, the common factor is 1. And if I factor that out, I'm left with x plus 4. So these guys are the same. And that's the common factor that I pull out in front for the factoring by grouping. So x plus 4. And then 2x plus 1. All right. So we did that work off to the side. So there's my x plus 4 and 2x plus 1. Well, then we have this guy right here who does not have a lead coefficient of 1. So if I do the AC method, 4 times 9 is 36. Let's see. So 4 times 9 is 36. Are there factors of 36 that add to 20? And yes, I can break this down as 18 times 2. So when I do that, that tells me exactly how I want to split up that 20x. All right, so I'm going to write this as 4x squared plus 18x plus 2x plus 9. I'm going to do factoring by grouping just like I did a second ago. All right, so the common factor in this first group is 2x. If I factor that out, I'm left with 2x plus 9. In the second group, the common factor is 1. And that doesn't really change anything, so that's just 2x plus 9. As we finish the factoring by grouping, we get 2x plus 9 times 2x plus 1. So just take a moment, go off to the side, do the factorization, and then bring it back into the problem. So 2x plus 9 times 2x plus 1. And then you've got that denominator of x squared plus 7x plus 6. This has a lead coefficient of 1, so this should be a fairly nice problem. Find the factors of 6 that add to 7. Well, that's going to be 6 and 1. So we have everything completely factored. We've got multiplication between these fractions, so it's a matter of finding common factors between the numerator and the denominator and then reducing those. So if we look here, we have x plus 1 up here and an x plus 1 in the denominator. So those guys get to reduce. We also see x plus 4. So x plus 4 reduces. Is there anything else? There's one more factor that gets to reduce, and that's the 2x plus 1. There's one in the denominator, there's one in the numerator. Now please understand that the only reason I get to reduce these guys is because everything is written in terms of multiplication. If there were to be addition or division, I don't get to reduce like this. It's only when things are connected through multiplication that we can reduce away those common factors. One on the top, one on the bottom. So the only thing that's left here is 2x plus 9 in the numerator and x plus 6 in the denominator. Now a lot of students want to try to factor more, reduce more, but you can't. Okay, you cannot reduce those x's because they're not factors. You can't reduce 9 over 6 because it's not just 9 over 6. It's this group 2x plus 9 and x plus 6. They have no factors in common. If I just had that as a fraction, yes, you would reduce 9 over 6. But with the addition, that means we're not able to look at those guys as having the same factor. So this is all that we get. All that work and so many things reduce away. All right, we got one more problem here. And for this last problem, we are looking at adding and subtracting. Now, the thing to keep in mind about adding and subtracting fractions excuse me, is that you have to have common denominators. And the way that we arrive at common denominators is we have to factor and see what every denominator is made up of. So take each denominator and factor. So this first guy is going to factor as x minus 3 times x plus 1. And then this guy over here is going to factor as x Well, you need factors of 7 that subtract to 6, so that's going to be minus 7 and plus 1. And then over here, we need factors of 21 that add to 10, and that's going to be 3 and 7, both of them negative. Okay. Now, we've seen problems like this before, or the same kind of process happen when we had equations at the beginning of the semester. So we get this, and now we have to get everybody to have the same denominator. That means make sure that there aren't any missing factors. So as I look here, just between these first two guys, they both have x plus 1 in common, right? But it's these guys that each one is missing. So this denominator is missing the factor of x minus 7. But here's a problem. I can't just put it in the denominator because it changes things, unless I also put that factor in the numerator, like that. Here, this guy's missing the x minus 3 factor that you see in the first fraction. So I'm going to put x minus 3 down here, and I need to do the same thing in the numerator. So now between these first two fractions, they both have x minus 3, they both have x plus 1, and they both have x minus 7. These guys are fractions with the same denominator. Great. But what is this guy missing? What does everybody else have that he doesn't have? Well, he's got the x minus 3, he's got the x minus 7, he doesn't have the x plus 1. So I need to inject an x plus 1 here, and I need to balance that fraction by putting it in the numerator as well. All right, so everybody has the same denominator. That denominator does not go away. What we're going to have to do is we're going to have to figure out what happens in the numerator and simplify all that stuff and put it over that common denominator. Now here's what I like to do. I've got a little bit of work that I have to take care of with those numerators. So I'm going to create my little thought bubble. I'm going to copy this down. So that was 3 times x minus 7 minus 7 times x minus 3 plus x times x plus 1. Again, this is just my thought process for tracking everything that's in those numerators and being able to simplify this without getting into, I don't want it to be all messy with all the fractions. So this is kind of taking this off to the side. So let's work this out. All right, so that's 3x minus 21. Distribute the negative 7, so that's negative 7x. Negative 7 times negative 3 is positive 21. And then distribute the x, so that's plus x squared plus x. And now it's just a matter of combining like terms. So let's start with the highest degree term, the x squared, and that's the only guy that I have. If you have a hard time tracking things, here's what I suggest. I've used the x squared, so put a little check mark underneath him. Now let's combine the x's. I've got 3x minus 7x, so that's negative 4, plus x. So negative 4 plus 1 is negative 3x. So negative 3x. So I've used that guy, this one, and that guy. And now I just have the constants left. So minus 21 plus 21 gives me 0. Okay, so done and done. Now the last thing we want to do is see, can you do anything else with x squared minus 3x? Can you factor this? And we can. You may not think so because there are only two terms, but there is a common factor of x that I can factor out, and I'd be left with x minus 3. So that's what happens with all of those numerators. Once you distribute, you combine like terms, and we factor. So, to make sure we see where everything is coming from, all of this is now equal to just one big fraction. So instead of us writing a bunch of smaller fractions and having to deal with all of that, again, we took the numerators off to the side and we worked them out. So my denominator is going to be this big common denominator of x minus 3 times x plus 1 times x minus 7. And one of the things you need to understand is that your denominator, it's made up purely of factors is written in terms of multiplication. So the order that you write those three factors, it doesn't matter. It does not matter at all. And then we got my numerator, which is x times x minus 3. Everything is factored, so now we can look to see if there are common factors that can reduce. And you see right away the x minus 3's reduce. So the only thing we have left is a factor of x in the numerator and the two factors, x plus 1 and x minus 7 in the denominator. And that's all we can do. So the thing to understand about this is to make sure that you do factor your denominators completely and correctly at the very beginning. And a lot of these problems that you're going to see either with what I give you or what you see in my math lab and really in most textbooks, you start to see some of these factors being repeated. Like we saw x plus 1 again. And we saw that when we got over here, we'd already seen x minus 3. We'd already seen x minus 7. If you find out that these two factors are totally different from both of these guys and totally different from both of those, and there's nothing in common whatsoever, go back and check your signs. Because a lot of times one wrong sign or one wrong factorization throws off the entire problem. Okay? But again, once you find those factorizations, you put in the factor that's missing, and we take those numerators and we work them out, and we put them back over our denominator. Now in the past, when we had equations, we cleared out the fractions. But you don't have an equation. You have an expression, which means the denominator is still going to be here as part of your answer.